today's video, I am going to tell you what happens if you introduce dielectric between the plates of capacitor. First of all, consider the capacitor. Here is the plate A and the plate B. The plate A is charged with positive here, and here is a negative charge that you know already. And today I am going to talk to you what will happen if I introduce a dielectric medium present between the plates. And both the plates are applied across the potential of V. And the distance between the plates is D. So the electric field E equals to V upon D. Call it equation number 1. And electric field is also given by E equals to Q upon A epsilon naught. Call it equation 2. We already derived these equations. Now we have the equation 1 and 2. Both are equal to each other. Implies Q upon A epsilon naught equals to V upon D. Implies Q upon V equals to A epsilon naught upon D. But Q upon V equals to C, that is the capacitance. And here we did not use any dielectric material, therefore call this capacitance as a C naught. C naught is a capacitance without use of dielectric material. Therefore C naught equals to A epsilon naught upon D. Call it as equation number 3. And the direction of electric field is directed from plate A to plate B. This is the direction of electric field. Now we introduce a dielectric material between the plates somewhere. So this is the dielectric material we have introduced between the plates of capacitor, that is the plate A and B. You see, on the plate A there is a positive charge, therefore on the dielectric material here the negative charge will be induced. And on the plate B there is a negative charge, so here the positive charge will be induced. Call this end as a C and here is a D. So the dielectric having the positive charge at the side C and dielectric material having negative charge on an external side at the point along the line D. And the direction of electric field in the dielectric material is from C to D, and let us call this electric field as EP and directed from C to D. The direction of electric field in dielectric material and the direction of electric field without dielectric material, they are exactly opposite to each other. Actually, when we apply the potential between the plates of capacitor with dielectric, then dielectric material undergo polarization, and due to polarization the electric field is produced. That electric field is denoted by this symbol EP, vector EP, and it is exactly opposite to the electric field between the plates without dielectric material. So both are opposing. So E is the resultant electric field. The resultant electric field between the plates is nothing but given by the magnitude of E naught minus the magnitude of EP. So E equals to E naught minus EP. Call it equation number 4. Since electric field is nothing but sigma upon epsilon naught for E naught, and for with dielectric material EP equals to sigma upon epsilon P, implies epsilon naught equals to sigma upon E naught, also epsilon P equals to sigma upon EP. Call it as equation number 5 and call it equation number 6. And we know that dielectric constant of the medium is given by epsilon p upon epsilon naught, implies K equals to sigma upon EP divided by sigma upon E naught equals to E naught upon EP. Call it as equation number 7. That is K equals to E naught upon EP, equation number 7. We have K equals to E naught upon EP. This can be written as a EP equals to E naught upon K. Call it equation number 8. You see, there are the two parts in the capacitor now. One part with dielectric material and the second part without dielectric material. So here is no dielectric material, and in this part the dielectric material. Let T be the thickness of this dielectric layer, dielectric material. So T is nothing but thickness of dielectric material. You can say dielectric layer. So D minus T is nothing but where no dielectric material is present. So thickness without dielectric material. We know that if V equals to potential difference between the plates and D equals to separation between the plates and E equals to electric field, then relation between them is given by the formula E equals to V upon D, implies V equals to E into D. That is V equals to E into D. Call it relation number 9. Now let V naught equals to potential difference in the region without dielectric and Vp equals to potential difference in the region of dielectric. Therefore, new potential difference between the plates V equals to addition of V naught plus Vp, where V naught equals to E naught multiplied by D minus T and Vp equals to Ep multiplied by T. Therefore, V equals to E naught into D minus T plus Ep into T. But here is a Ep and this Ep is equivalent to E naught upon K. Therefore, V equals to E naught D minus T plus E naught upon K into T. So V equals to E naught taken common D minus T plus T upon K. Call it equation number 10. But E naught equals to V naught upon D. Therefore, V equals to V naught upon D into D minus T plus T upon K. Call it equation 11. Now, capacitance with dielectric C equals to, let us call it as a Cp. Cp equals to total charge upon potential. So Cp equals to total charge is Q and total potential V naught upon D into D minus T plus T upon K. Therefore, Cp equals to Q upon V naught into D divided by D minus T plus T upon K. But Q upon V naught is equals to C naught, implies Cp equals to C naught into D upon D minus T plus T upon K. Now Cp equals to C naught into 1 upon D minus T plus T upon K divided by D. Therefore, Cp equals to C naught multiplied by 1 upon D minus T upon D plus T upon Kd, which is equals to C naught upon 1 minus T upon D plus T upon Kd. So Cp equals to C naught upon 1 minus and T upon D can be taken common. So we get here 1 minus 1 upon K. This expression gives expression of capacitance with dielectric material is present between the plates of capacitor. Now consider a special case where T equals to D, that is thickness of dielectric equals to distance between the plates. This was the distance between the plates. So consider T equals to D. In such case, Cp equals to C naught upon 1 minus D upon D 1 minus 1 upon K. So Cp equals to C naught upon 1 minus 1 plus 1 upon K, implies Cp equals to C naught upon 1 upon K, implies Cp equals to C naught K. Thus, by introducing this dielectric material of dielectric constant K, the capacitance increases by K times. So Cp equals to C naught into K. Now let us conclude. The capacitance of parallel plate increases on the introduction of dielectric slab. And second conclusion, capacitance of parallel plate increases by K times, where K is nothing but dielectric constant of dielectric material. If you are really benefited after watching this video, then I request you like, share and subscribe the channel. I keep on producing the videos related to physics. Meet you again with another topic. Till then, wish you good luck. All the best.